Okay, so this is solving absolute value equations. This is 2.3, the second portion of the notes. So let's discuss what absolute value means really quick to kind of refresh our memory. Absolute value definition is the distance from the origin. When you think of distance, you need to think of positive. So if I have the absolute value of, let's just say I have the absolute, here's my origin, and I go here to 2. The distance from here to here, I want to get there, is 2. If I'm here at -2, the distance from here to -2, I'm talking about distance, is still 2. 2 steps, whatever it takes, 2 jumps, measurement, 2 units to get from the other. Thinking of positive, walking it from one side to both directions, whatever, I'm talking about a positive thing. So the reason I want to talk about that is because if I have the absolute value of x equals 2, I have 2 possible choices. I can go to this positive 2, so when x absolute value of 2 equals 2, which is true. And then I can, if I want to go this way, so the absolute value, again, going this direction, it's -2. Well, the distance between that is a positive 2, so that's the same. So when I talk about if I want the absolute value x equals 2, I have 2 possible answers. I have x can be -2 or a positive 2. So when we think about that, when we're talking about solving equations, we want to talk about writing 2 equations. So when you start these problems out, you should always write 2 equations. Okay? So the first one we think about is just straight up absolute value on one side by itself equals a 7. So I'm going to first write 2 equations. I'm going to drop the absolute value and write what I see. Now my second equation, I'm going to think about that going to that towards that -2. So I'm going to drop the absolute value, but on the other side, I'm going to take the opposite of that 7, and I need that to -7. Okay? So now just solve for x. Here x equals 12. Here x equals -2. If you were to substitute both of those back into the original equation up here, you get this right. Do not have to check these. Now, if you want to check if you feel like your math is incorrect, then you could do that, but you don't have to check these. So let's start with number 2. Now, number 2 is not like the other one. This 5 is in our way. So we got isolate it, is what we say that you learned in last year in Algebra 2. You have to isolate it. So you're going to make the absolute value by itself. This next step is please, 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 is so important, okay? When I divide by 5, I am left with the absolute of 5x minus 10 equals, and 45 divided by 5 is 9. Notice I have not dropped the absolute value sign yet. So please be careful that you don't make a silly mistake and write this, okay? Now I can write my 2 equations, my first equation being 5x minus 10 equals 9, and my second equation being 5x minus 10 equals a -9. So it's the opposite of that 9. So solve for x, you get, we get x equals, add 10 to both sides, 19 over 5, and here you get x equals minus 10 from both, add 10 from both sides, you get 1/5. Again, you could check by seeing if this works by substituting that in. Okay, so let's look at number 3. Oops, sorry about that. Number 3. So when I look at number 3, I'm just going to move the 2 over. Minus 2. Again, do not drop the absolute value sign yet until you've made sure that you've done the math and put everything on the other side and isolate that absolute value sign. So now go ahead and write 2 equations. So my first equation will be 3x minus 2 equals 13. My second equation will be 3x minus 2 equals the opposite of that of that 13, excuse me, will be a -13. Now solve for x. I'm going to pause here. You solve it and see what you get. Okay, so now that you've solved for x, you should get negative x equals a positive 5 and x equals negative 11 over 15, excuse me, over 5. And that is correct. Let me rewrite this. This looks a little... Okay. So now let's look at number 4. Now I want you to think about what this looks like. I'm asking you to take the absolute value of a negative number. Now we can do all the math, we can go do it. So at this point, we're hoping that you recognize that no matter what you put in there, no matter what value you pick for x, when you do all the math and take the absolute value of it, you can never get a negative number. This is not a possible situation, okay? So this, not possible. I can never take the absolute value of something and then get a negative number as my answer, okay? So when I write the abbreviation for absolute value, it's going to look like absolute value signs with the squiggles in there. So absolute value always, always, always produces a positive outcome. Okay. I want you to make sure that it's not the same as getting a solution that's a negative value. You can have that, but no matter what, you take the absolute value of no matter what it is, it will produce a positive outcome, never a negative outcome. So this answer here will be no solution. Now, when you see something like number 4 up here, then you can write no solution. But make sure you understand that I can quiz you at this point in your mathematical career. You should be able to understand that what this is happening, why it happens. You got to understand what's going on based on this information here. So make sure you understand that if you're asked in some sort of form to be able to answer it that way and tell me why it's no solution, be able to do that. Okay, now starting with number 5, if you notice that we have absolute value equals, and then we have a variable on the other side, okay? So at this point, just like you did in square roots, now is the time you're going to have to check, okay? So I always forget to change it from one to the other. I'll get rid of that. Okay, so note, all right, check solutions when there is a variable on both sides. Okay. So now we're going to do the same thing. It's isolated. Absolute value is by itself. And then I'm going to equal 4x. So I'm going to do the same steps. Divide two equations. Number 1, drop the absolute value and write what you see. Second one, number 2, drop the absolute value and then do the opposite of that other side. So it's going to be a negative 4x. Okay, right now I want you to solve for x. And I'll come back and check. Okay, so I got x equals 6 and x equals negative 2. So at this point, what I want to do is check it. Since it's got a variable on both sides, we're going to check. So we're going to check each side, check back into the original. So the abs value of 2 times 6 plus 12, does that equal 4 times 6? And over here, this is 12 plus 12. So does the absolute value of 24 equal 24? Yes, that is true. So this is a solution. Now let's try negative 2. So we're going to check here. This does take room, so make sure you have room to write things. So if I do 2 times negative 2 plus 12, that has to equal to 4 times negative 2. So I'm just going to go here and write negative 4 plus 12 equals a negative 8. Now I can stop right here because based on question number 4, Let's zoom in a little on that. Okay. So based on number 4, if we have the absolute value, then it cannot equal a negative number. Well, that is what's happening right here, is it doesn't matter what's in here. I can still do the squiggly. Whatever the absolute value is equal to this -8. Well, that can't happen. So therefore, this one will never work. Now, let's say that you didn't see that and you just went along. -4 plus 12 is a +8. So the absolute value of a +8, does that equal -8? No. So this is false. So it's still, that does not work. So x equals 6 is your only solution. Let's do number 6. All right, number 6. So you have the absolute value of 2x plus 5 equals -3x. So now we can write just 2 equations. Everything is already isolated for us. So you drop the absolute value, write what you see. Number 2 equation is 2x plus 5, and the opposite of -3 is a +3. Okay, so now we're going to solve. So I'm going to pause. Okay, so I have x equals -1 and x equals 5. What I kind of question really quick is that if you notice this looks a lot like this equation and the one above may look the same, but they're not exactly the same, as in I can't just say it's no solution. If you look, I have -3x, okay, where over here I just had a -5. So I can make x a negative number, and if I substitute it in here, x is negative, negative times negative is positive. So I cannot say it's no solution because of that. So I still have to check. So let's check. Okay, so checking. So the first one, when I did the -1, I did get it to work, so this is a solution. But when I did 5, notice what happens. Here's my absolute value of something. Does that give me a negative number? I can't do that, so therefore this is not a solution. That's extraneous. Okay. All right, number 7. Okay, number 7, again, I need to get the absolute value by itself. It's not, so I'm going to move that +7 over. So I'm going to have, again, I'm not dropping the absolute value until I have moved it over, so I'm not making a mistake with my 2 equations. Equation number 1, so I drop it, write what I see. Number 2, drop the absolute value sign, but again, I'm going to take the opposite of the other side. So it's a negative, and goes in here is -7x minus 7. Okay, so you do not have to do this one step I did over here. I was just making sure that you can see that I am subtracting that whole entire side. Okay, so now solve for x. And come back and check it, and let's see how we did. Okay, so I have 2 solutions I got. I have right here x equals -5, and then I got x equals -1/3. So I went ahead and did the check for x equals -5, and it does work, so that's a solution, went through it. So now on the second one, what I want to kind of look at is like, sometimes you don't have a calculator, you're like overwhelmed, but I want you to kind of think of, take this wrong, it was common sense, something to think about when you look at. This whole left side has to equal 7/3. Well, 7/3 is the same as what? I can write 7/3 as 2 and, we can go 2 and 1/3. Well, no matter what, this 7 right here is larger than this 2 and 1/3. So logically thinking that this side is greater than 7/3, they will never be equal. So therefore, this doesn't work. Or you can do all the math and show that it's they don't equal each other based on that. But knowing that you understand the logic of it, that the left side cannot equal the right side, it is so much larger, and so therefore it can't be a solution. Okay, last problem. All right, we are going to do Absolute value, this, it's already isolated the absolute value sign, so we're going to write our two equations. So number 1, 2x minus 9 equals 3 plus 1 half x. And the second equation we have is 2x minus 9 equals, now I'm going to take the opposite of everything up here. Well, that's all positive, so it's going to be, I'll just put the symbol negative 3 minus 1 half x. Okay, so now we're going to just, we're going to solve. So I'm going to stop the video and you solve and tell me what you get. Okay, so what I have so far is I have here x equals 8, and then I have x equals 12 over 5. So let's check that and make sure that we have that correct. So if we substitute, this side's a little easier when we have that whole number. So I check. Yes, I know it does take time. It does take space, but not everything in life is quick and easy. Same thing with our math. It's not always going to be quick and easy. Some things are hard. So now we're going to solve. We get 16 minus 9, which is 7. So the absolute value of 7 is just 7. And then over here, we're going to have 3 plus half of 8 is 4. So does that equal 7? Yes. So this is a solution. The other side, let's check. So we're going to have, let's check here. All right, so we're going to have 2 times, I'll write this a little messy here. Give myself some room. So we have our check. So absolute value. On the left, we have 2 times 12 over 5 minus 9. Does that equal 3 plus 1 half of 12 over 5? So let's solve. So this is going to give me 24 over 5 minus, well, if I want a common denominator of 5, then I'm going to change this to 45 over 5. 45 over 5 gives me 9. When I subtract, I wind up with what? Negative 21 over 5. And so that's the absolute value of that. So that's going to be a positive 21 over 5. Okay, so does that equal the same thing over here? So here I'm going to do 3 plus, and I'm the one that likes to reduce as I go. So this is going to reduce to a 1, and this will reduce to a 6. So I now have 6 over 5. Well, common denominator for both of these would be 5. So this becomes 15 over 5 plus 6 over 5, which equals 21 over 5. So it checks. So both of these work. Okay, so just kind of recap on what you make sure you do. You're always going to have to write, isolate the absolute value, write 2 equations, make sure that the second equation is always the opposite, taking the opposite of what you have. And then check. You only have to check if you have variables on 2 sides. So let's kind of look at this note. It says, what do you notice is the difference about the equations from examples 5 through 8 compared to 1 through 4? So let's see, 5 through 8, we have this and this. Here's, that one's highlighted already. Okay, so look at those carefully. And then when we look at 1 through 4, what do they look like? This one and this. Now we're comparing these two. So if you notice that there is a variable, okay, outside of the absolute sign, for examples 5 through 8, or 1 through 4, there is not. Okay, so we're going to write they have a variable outside the absolute value. And there's my little, okay. So that's the difference between the two. And then we know when that happens, when do you check your solutions for extraneous solutions in absolute value equations? Sorry, let me spell that better. When there is a variable in and out side of the absolute value. So again, knowing how to answer these questions, if this was given to you a question on test, can you understand what's happening and what's the difference in when you need to do that, okay?